Well, hi, good morning. Thanks for coming and joining me. You can see I cleared my bench all off. Get started on a new project, but look who's back. Yeah, I ended yesterday's video with a certain amount of depression, thinking that this is an impossible radio to fix. The main reason is no schematic I could rely on that would show me what this really should be, and it just looked like there was a number of things maybe different people did over time. I don't even know if the tubes are correct. So after yesterday's video, I pretty much concluded I'm just going to beat my brains out trying to do this. I got better things to do than work on this guy. But guess what? It's on my bench again, and the reason it is this. Okay, so what you're looking at is a schematic which matches the radio I have here on my bench, but in fact lists different model numbers down here. So someone else, thank you very much, sent me photographs of the Model 81 and 81, 82, 83, and my own radio. They're very, very, very similar. The Model 81, 82, and 83 are plug-in models. The Model 93 that I have on my bench, well, you know, the only reason I think that's a Model 93 that's on my bench is because there's a sticker on the back of it, or a plate, that says 93. You know, maybe it just comes down to they put the wrong plate on this radio. Maybe that's all it really is. But in any case, oh happy day, here's a schematic that fits the radio. Look, 6K6, these are the tubes that are in there. 6K6, 6F6, 6Q7, 6A8, 6E5. Okay, so this tube is not in this radio. And the 6E5, this is a magic eye. And this is also not in this radio. Maybe that's why you can't call it an 81, 82, or 83. It really isn't. It's missing. It's different circuit-wise a little bit because this tube doesn't appear. And it doesn't have a magic eye, which magic eye was a big selling feature when they marketed these radios. Everybody wanted a magic eye. And they are cool. These are cool. I like these things. So this gives me anyway, a new lease on life with this radio. Just ignoring the 6C5 for a minute, and bear in mind that there is a empty socket in the radio I'm working on, and perhaps that really had a 6C5 in it at one time, and maybe I don't know. 6C5. It's not where I thought it was. Come to think of it, now that I look at it, what is it doing here? Well, whatever it's doing in this radio, it's not doing in mine because I don't have it. So I'm going to just ignore that. Look at this thing over here. Tuning meter for Model 81 only. A tuning meter. So I think I can see what they're doing here. They're putting a screen or plate current right through the meter. Wow, that goes up to a switch. I think that's what's going on here. This meter actually tips based on plate current, I think. But anyway, that's also not in my radio. Here's the battery. This is in my radio. So we're going to take a closer look in a moment. Well, it won't be a moment. Well, it'll take a little bit of time. Down here's the power supply. It's an 80, same as the radio I have. What's it got going here? It's got the winding for the rectifier, and then a winding for the rest of the tubes. A couple filters. Now, is there a field coil in here? Look at the speaker here. For models, valve symbols looking at the bottom. Well, I think this is a field coil here. Not quite sure. This is the audio transformer. In the radio I have, this is mounted right on the speaker. Yeah, you see how this wire comes down here, disappears into the plug, almost certainly goes through here, comes back and on its way. So this coil, from my quick look here, this coil appears to be the filter coil in the power supply. So this radio I have doesn't have a speaker with a field coil. So it's filtering the power supply some other way. Let's see, this is a 12 microfarad, 26 microfarad. Okay, so I put two 50s in here, a 50 and a 50. If I remember right, did I do that? Or did I put two 20s in there? What did I do? I can't remember. You know, I'm going to flip the radio up and just take a look here. Let's see, very quickly. What did I do? 22s. I put two 22s, and look, this one's actually supposed to be a 26, and this one's supposed to be a 12, and that's what this field coil in here, choke coil. Wow, in my experience with these things, this choke coil style power supply, where you got, you know, capacitor, coil, capacitor in the power supply, really, really effective. Even when the capacitors get weak, it's still very effective. And I think there's some humbucking stuff going on in here too, by the way. So when we say effective, or when I say effective, I really mean you can't hear the hum coming out of the speaker. It could be the hum is all through the radio, but at the last minute, it's counterbalanced out of here in some way. So, you know, maybe I've been fooled by that. I don't really know. Never really investigated all that stuff. So very good news. Now, why don't we take a look at what is an issue right now, which is, flip back to the camera here. Okay, so the last thing I was looking at was right here. See, I really put this out of my mind, didn't I? So this carries the screen voltage up into the tube here. This device, this component, appears to be open, this red thing, you can barely see it, which is a very unusual looking component. So, and this capacitor, oddly enough, seemed to test good. That's really quite odd for that. So I'm going to cut these guys out. We're going to test these two things, going to find out what this red thing is, because maybe it's not a resistor. Maybe it's not a capacitor. Maybe it's something else. I find out what this is. Hey, I should find this on the schematic now. It's okay, just getting used to having a schematic handy now. Okay, so this was pin number, I can't remember. Pin number, I can't remember. On tube number, I can't remember. Okay, so that's a 6K7 there. So quickly, 6K7. Maybe even read a little more about the 6K7 here when I find it in my book. Okay, 6K7. Metal type 6K7 and glass octal types 6K7G and GT used in RF stages, particularly those employing AVC. Okay, outlines, blah 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 blah. Well, not much in here. Just this little right up here. That's not going to do much for me. The screen. So there isn't even a table of voltages. Come on. It must be must refer to another, you know, same as another tube. For heater and cathode considerations, refer to 6AV6. Heater, well, typical operation, maximum ratings. Does it name another tube here? No, it doesn't. Oh, it's all just written here. It's all written out. They didn't put it. They didn't tabulate it. Oh, for crying out loud! Okay, grid number 2 volts, 125. And by the way, the bias is supposed to be -3. So grid number 2 should be the screen grid. 125 volts. Doesn't give me any more hints. Doesn't tell me what kind of resistor or anything. Occasionally these books actually contain a lot of information about, you know, the circuitry around the tube in question. I'm going to cut those guys out and we're going to take a look. You know what? Maybe I think I'm going to try desoldering these because they look they look like they're not soldered in particularly well. It's actually much easier to see on camera than it is looking with my my eyeballs. I don't know if that's tacked on there. We'll find out in a moment. Here we go. Yeah, just fell right out. How do you like that? Here's what we've got here. Come on, camera. What do we got? So I wondered if this thing had been burned. It doesn't really look like it. It looks like some exterior color loss. Now, interestingly enough, on this guy, which I tested yesterday and tested really good. It looks like it's very, very sealed. Well, you know, maybe this is the lucky one. I did get a note from somebody saying they thought these sealed tight ones, I think he said when he was trained in doing this kind of work, he was told sealed tight capacitors gotta go, they're all crap. Well, there's one that's made in, what's that, Bayonne, New Jersey. Okay, so I'm gonna retest this thing right now and see what we can see out of it. Oh, I want to find it on the schematic too. Oh, there's just so many things I want to do. Let me just grab my... Okay, I'm on the 20,000 ohm scale here. This thing tested open when I tried yesterday. Well, that's doesn't get much more open than that. So it's whatever it is, it's open circuited. Let's find it on the schematic now and see what the schematic shows. Oh, that's why I want to know the pin number for the screen. And there isn't even a cat in here throwing me off. 6. So sorry, I gotta look this up again. 6K6, 6K6, 6K7 rather. A screen is pin number 4. Pin number 4. Okay. Let's go over to the schematic here. Okay, now we're talking about this 6K7. No, we're not. We're talking about the 6K7 right in the front end. So we're talking about this one here. And we're talking about pin number 5, which is right here. Wow, it's really... This looks like... The screen looks like it's 4 here. The suppressor is 5. Okay, well, we're looking at this. Let's just follow 4 then. 4 back. 75 volts. Oh, there's no componentry. Not here. Okay, well, I don't know. Let's look at... let me just show you why I'm laughing here, okay? Just give me one. Bear with me 1 second here. It's very hard to do now. I'll show you why. This is why I'm having trouble. I've got a gap between me and my computer screen here. Come on, I can't see anything through it. What did I say about, hey, it's a good day. No distraction from cats. Okay, come on. Down you come. Down you come. In fact, I won't put you down because I know you want to be up here. I'll put you over here. Stay over here. Okay, back to what we were looking at here. Right. Now I'm all distracted. So if we follow the suppressor, it should simply go to ground or something like that. Yeah, there it goes, right to the chassis. So let me look at this once again. Pin number 4 is the screen. The screen grid is in a tube to control the reduce the inter-electrode capacitance and make the tube less likely to actually feed back through itself to itself. I guess is a way to put it. Uh-oh, cat's back. No, there's no components until we get way over here. $75 volts. Well, I think maybe what I should say is this schematic probably bears a lot of resemblance to the radio I'm working on, but it may not be identical. So I measured the screen voltage on the other side of the red thing at about 350 volts. And we want the screen voltage, according to this schematic, to be down around 75. I see the plate voltage is written there too, 275. But in this radio, it's much higher. Wasn't it much higher? You know, it wasn't actually, come to think of it. It was halfway up on the meter on a 500 scale, so it was about 250, 275. That was with the AC voltage, the incoming AC voltage reduced. Yeah, this is what it's come down to. There, I'll let you hear him purr. Her purr. This is a her. It's a her. Oh, oh, oh. But she's really not a cat for being held. As soon as you pick her up, she's looking for some way to get going again. But she's a little miscurious. Okay, let's get back to this stuff now. Gives you an idea how I do things in the shop there, seeing me at the computer that I use to make these videos. So we're not going to find out the value of this by reading it. It's open. So I think what I'm going to do, I'm going to smash this thing apart here. There, down here a little bit. What do you say we do that? Smash it apart and see what's inside. Maybe it's a coil. Well, it looks like a resistive component. It looks like a carbon shaft to me here. And so I think it's a resistor. I should say it was a resistor. Now it's just a pile of debris. So a resistor of no known value. But we need something based on the expected current coming through the screen grid needs some kind of resistor to drop the voltage based on that current. I don't know what that current is. So it looks like we're going to have to fiddle around here a little bit. Maybe use a decade resistance box or something and try to sort it out. The challenge there is the screen current can be a little high. And you get the wrong combination of resistor, current, voltage, and the next thing you know, your resistor's on fire. Resistor on fire. Oh my gosh. Cat. So clearly something significant is needed there. Let me think a bit. Let's make some assumptions. Let's make some assumptions. I'll write it down on my piece of paper here. Okay? What do you say, Shadow? Good idea? Let's just, because I don't have it in the top of my head, let's pick any tube with a screen and see what kind of current's on it. Okay, so this is a beam power tube, so this is a bit of a tube number 4. And a 6BQ6, just to give me some idea. Plate, maximum ratings. Grid number 2. Grid number 2 input. God, come on. 2.5 max. What do they mean by that? 2.5 max. Oh, that's in watts. Am I reading this right? Grid number 2. Oh, I don't want it in watts. Give me something in milliamps, please. Plate current, heath current. Ah, okay. So much for that too. That didn't work. 6AV6. Didn't they say that was the same as a 6AV6? 6AV6 in some ways. No, that's totally different too. That's crazy stuff here, man. Okay, here's a sharp cutoff pento. Never heard of that tube. 6A. Let's take a look. Screen. Grid number 2, rather. Grid number 2 supply voltage. Grid number 2 voltage. And now show me the current. Grid number 2 input. Let me give it in watts again. Okay, this isn't working out. I thought it would list a current. Okay, let's make up. Let's just make it up. Okay. How about a screen current of 10 milliamps? 10 milliamps. And we got a supply, I think it was, well, let's use 300 volts. 300 volts. And we want to get 75 according to that schematic. So we got to get rid of almost all of this, 225 volts. So we take R equals V over I equals, what's this, 225 over 10 milliamps. Get the million, make it a K, divide by 10, you get 22K. 20K. So that's a good starting point. We can start there. Oh, well, I got to do a wattage calculation here. My cat is now riding around on my bench. It's a good thing my other cat doesn't jump here, because my other cat weighs 17 pounds or 16 pounds. So it would just fill this bench up with cat. So the wattage on here, if you have, let's see, I squared R, or EI. EI might be a little easier. EI. So E is 225. I is 10 milliamps. So I go 2, 2, 5, 0, 1, 2, 3, 2 watts. 2 watts. See? See? Now, this little resistor that's all burned up here, first of all, we probably know why this guy left the planet. He just may have not been able to take the current. And especially in his older, dilapidated state, maybe not. But that's not a high wattage resistor, I don't think. Or maybe this is. Maybe this is some style. You know what? This covering here is kind of a ceramic. So you know what? You know what I think? I think that's a high wattage resistor. Small in size. So, okay, so well, for sure, if I put a big wattage resistor in there, we won't have any trouble. I could put a 2 or a 5 watt resistor in there. I got lots of them. And the resistance I worked out to be, to put off my calculation, 22K. 22K. A fairly high wattage resistor. I got some options here. Why don't we try? So I think these guys are high enough wattage. And if I burn this up, it's not a big loss. So 22K. This is, by the way, this is how I store my capacitor, my resistors. So this contains resistors in it that are potentially 2 ohms, 20 ohms, 200 ohms, 2000 ohms, and onwards. Then all I got to do is say to myself, okay, so if I want the 22K, then I should be looking for something in here with an orange band. Now you said look for the orange band. We go very quickly. I got it in my hand already. Orange band. There you are. Just like magic, 20K. So that's how I sort these out. I don't put them all in individual trays and stuff like that. Do it like that. Let's get rid of this stuff here. Goodbye. You might as well go too. No, you know what? I'm going to hang on to this and test it again. I'll put it with a collection of capacitors for testing. Now, another thing that's got me a little excited about this, after yesterday's session, I kept thinking about things. I realized what I had found was a screen grid that's not powered. And I don't know if that's really enough to silence the tube. I'm not sure. I'm just not sure about that. If it is, if having no screen voltage is enough to silence the tube, then that explains a lot about this radio not working. And now, let's go back on this camera here. Now they've used wires here that have frayed badly right at the connection point. It's hard to see around the fray. This is so rotten, I can just grab it and pull some of it off here. Just so I can see more clearly between the two terminals. Because I really like to see my mistakes well before I make them. For that. I'm not going to put a capacitor in here too. I should get it. I should get it and do the wind around thing here. That was a 0.05, wasn't it? 0.05. Grab a 0.05 here. Just got the longer, heavier lead. Just kind of duplicate the way it was in there. We'll stick that in there. I think there's a hole I can get through. Yeah, perfect. Now, this end of it here is going up around here. So I just gotta make sure I got enough. Oh, I got lots. I can do it like that. Just put it there temporary, like that. This one is coming down to meet up with this wire here. So I was watching the news and weather this morning, and on my TV is a story about the conditions in Europe right now, and Britain, England. Tremendously cold weather, snow falling, and not a small amount either. And while countries like Canada might be a little better prepared for snowfalls like that, it still disrupts everything. Don't get the impression that snow is, you know, Canadians are impervious to snow, and that's not quite true at all. Depends when it falls. You know, if it falls during the week during rush hour, lug out. No rush hour in Orillia anymore, or here in this town, but where I used to live, I lived right near the busiest highway in North America, like 1 kilometer from it. Big wide multi-lane highway goes right through the middle of Toronto. It used to go around Toronto, but Toronto has swollen so much, like all cities in the world, that it's encapsulated this super highway right through the middle of it, and everybody commutes on it. Well, everybody tries to commute on it. I lived right near that highway, but one of the reasons I moved up to this town was to get away from that kind of stuff. Wouldn't it be something if I do this, turn this guy on, and it actually works? And you know, there's a good chance that's what's going to happen here. Because I remember hearing some hissing and popping coming out of this radio early on. Oops, I would like it to hiss and pop again. Oh, that's a drag. I just dropped my solder here. And I have retrieved it. Okay. An interesting question is, if this thing made sound, this radio, when I first got it, and then it stopped, and it has something to do with this part I've just replaced. Clearly this is not good for it, having a no screen voltage. To get there. Okay, now the last thing. There's a huge amount of stuff here to heat up with my soldering iron, so I don't want to heat this whole thing up. Hopefully I can just melt some of the existing solder and kind of weld it. cold solder joint there. You know, I should have, you know, back off, back off, back off, back off, back off. Change the plan, change the plan. Isn't there a wire sticking out here? Yeah. Okay. So I'm going to go on that wire, which is in behind here where I can't see it. There we go. You know what? This is a bit of a problem because this is right on the bottom of the radio here. Is this actually sticking out? If I'm not careful, I'll make a joint here that'll stick down when I put the radio down. It'll be rammed up this way. Rammed up. So I want this to be a little off to the side there. I can trim a lot of this away too. Okay, let's solder that and then let's do that. So I'm feeling kind of sorry for all the Brits and Europeans who are having to put up with a lot of cold weather, which I understand is air from northern Russia. Arctic air coming over from northern Russia. That's what I understand. Kind of an unusual weather pattern, I think. I think I got it. I think I have it there. I think that's sticking out. Just barely. It might touch down a little bit, but there won't be any pressure on it of any significance. So that's good. Okay, so we got the resistor. Wait a minute, I got another resistor spot to solder here. The solder's taking on the not looking so good there. Let's try a little bit of rosin on it. Once again, I've put it down here somewhere. Jeepers creepers. Sorry about letting some dead air go over on my video. I'm gonna look around here. Can't find the rosin. Okay, a little bit here. There we go again. Probably got soldered well enough, like good enough, but let's just see if we can get a little bit better. Ah, that's lovely. Doesn't look so good on the camera, but it's actually, if you look at it from above, it looks a little better. Yeah. I'm sure it's electrically connected at this point. Yeah, that's good, that's good. That's good. Okay, now we know what we're going to get the chance to do. Turn this guy back on. Except, where's the speaker? Put the speaker back in the cabinet. I'll have to take a little bit of time to get it out of there again. Okay, let's get this guy ready for another test. Off. Plug has been wired correctly. The reason I mention that is sometimes these plugs have been put on by amateurs or radio homeowners, or when they're putting a plug on, it's not too tough, eh? But there is actually a trick to doing the wiring right to reduce the chance of a short developing right in the plug. If you don't know the trick, there's a good chance you'll throw the wires into a plug like that, and a little bit of tugging and pulling, a few frayed strands, and next thing you know, right in the plug you got a short. That's why I like to look at them at least once. Okay, I think we're all set here. Holy smokes, really? Maybe an antenna. Maybe an antenna would be a useful addition here. Kind of a hopeful thing, isn't it? Putting an antenna on there, it means I'm anticipating it receiving something. Okay, I think I'm ready. I'm going to do the dim light thing once again. Oh, there's a chance. You know what? That resistor I put in there may burn right up like that. So I think maybe it's smarter for me to tip this radio up on its side and have the underside exposed, so I can detect that, so we can get it on camera. It'd be a thrill. It'd be a thrill. Yeah, let's do that. Up you go. Up you go. There we go. There. Nice and stable. So we want to keep our eye on this resistor here. Wow, okay, right down there, a little hard to see. Get my thermometer ready. 22 degrees is the reading here. I keep my house furnace set to 23 in this house. Okay, I don't think there's much more to watch for. Now, if this thing is going to overheat, it's going to happen fast. Okay. Other things, let's see. Volume. Volume is about 10-15%. Band switch. Band switch. What did I do with the knobs? See, I packed this whole radio away yesterday, thinking I was done with it. Maybe I'll be packing it away again shortly. So this is the band switch. So I think that's AM band. And remember, different operation on different bands. One quiet, two making sound. Okay, I think we're ready. We see the dim lights up here. So you gotta watch those lights. Watch this resistor. And of course, we're gonna put it on with restricted. We're gonna fire it up at about 90 volts supply first. Now this thing here, by the way, this is reading the average thermal whatever within view of this opening. So I put this up against the resistor. Even like that, I'm not really reading the resistor. I'm reading the average of everything it can see, including that resistor. So it's not an absolute reading at all. But if that resistor starts going up, we'll know it on this thing. There's no metal on it, eh? Nope, it's good. Good. There we go. Ready for this. Dim lights first. Good. Resistor. 21. 21. Nothing happening here. Oh, 20, 22. Oh! Holy. $25. So this can go up to like 50, I think, before you have any concern about it. Although at 50, you got to be worried about adjacent componentry. It's laying up against something. 27, 29. So something else down there? I don't think so. 30. So it's warming up. Let's check some other stuff in here now. See if we see any heat anywhere. Just turn this so you can see it too. What would be warm down here? Is it or not? It's kind of weird. It's like this switch. Oh my gosh, this is the power switch, and it's heating up. This is the AC power switch here. Really? 25. So the neutral temperature is 21. Ambient, I guess is a better word, 23. It's got to be the switch. That's not so good. Keep an eye on that. What about this coil? No. Anybody up here? Put it right up in here. Aha! Something up in here. Okay, so I have the high wattage resistor here, which is the cathode resistor, which is expected to dissipate some power. So I think I'm getting like a 25 on that. That's nothing. And up in here. Here. It'd be great if I had one of these units with a screen on it. Maybe I'll do that someday. They're expensive. Okay, let's go back to our screen resistor. 27, 37. You see the 37 go by? 34, 37. That's getting warm. And the switch here. 25, 25. A little bit of heat in the switch. Ow. Hey, this radio's working. Let's tune it. Ah. we're in business. We were. The string is slipping over here, so I'm turning the knob, but the pointer sometimes it's slipping. That's French. A little volume. The speaker sounds okay on low volumes here. Let's find some music. That's hard to do. AM band. So this radio was receiving on a junky little wire antenna. Let's go the other way. It's the same one. So that means I did get this coil connected. .640 Toronto. Not going to find any music on the AM band. Hey, let's go to shortwave here. It's working. Oh yeah. So I think we're on what band now? We'll be on. I think if I remember right, this is the shortwave high. So if that's the case, let's see, shortwave high. It's going to be this pointer. So somewhere around 5, 8, 10, 14. So maybe up in here we might get some stuff. Based on the time of day. Hey. Little band indicator is somehow rotating with the dial. More volume. Okay, so this control, the volume control, it sounds like the slider is lifting a bit. I got a sweat on my hands there. Ah, what's that from? Excitement? Okay, we could pick up anything now, anytime now. It's getting quiet. So the rattly part of that sound you just heard is the speaker cone. It's being thrust a distance, and you can really hear the lousiness in it now. If you're just listening to music or sound, you know, it's barely moving, right? It's just the cone is barely moving. Come on. Okay, we're up around 14 now. What is doing that? So remember that this whole thing is not mounted securely. Scared the living Jesus out of me. Come on. Pick up something. Some religious stuff from the States. Doesn't want to cooperate. That's the end of the road. Yeah, the capacitor is fully open, so this pointer should really be pointing up here. So that makes 15 here on the scale. Actually, they have it marked there. That's the 19 meter band, but with the pointed, bent pointer, they need to be more down in this area. Come on, something, anything. Okay, fantastic. I'm going to leave it at that right now. It could be it's not receiving for a couple of reasons. One could be antenna is insufficient. Number two, wrong time of day, there just isn't anything out there, there's something going on with the sun, and there's just no shorter wave to pick up. The last one, the most likely one, is alignment issues have made the radio insensitive. Probably the alignment is what is required. The great news is, along with gaining the apparently reasonably correct schematic, I've also got all the alignment instructions. So thank you very much, you who sent it to me. It's fantastic. And a number of you have sent quite a bit of stuff to me on this radio. That's one of the reasons I have it back on my bench, because I realize this isn't only under my skin. It can be under your skin too. And it would be very disappointing for you who are a viewer watching me trying to do this stuff and you think I'm close to doing it and I give up. Well, that would be very, very frustrating. So I don't want that to happen. Plus I tend to not give up. Has anybody noticed that? Yeah, I've made it through life with the power of persistence. Fantastic. So I think the next thing I will do with this radio is we will poke around a few voltages here and there, just poke around a little bit and see if it isn't actually working really well. Biases are correct, things like that. Then we'll go right into the alignment and try to bring up the performance. If the performance comes up in the radio, then we can assume, hey, this is actually in pretty good shape, regardless of all the other problems in here. But there's still paper capacitors and other stuff in here. Isn't there paper? Yeah, there's a paper one way down there. But if it kind of starts coming more to life, it's already really good, in fact, from my point of view in repairing radios. But if it comes really much better, then maybe I'll go in and change out all the rest of these capacitors, because there's value is beginning to build up in the radio. And the cabinet can always be restored to look like new for anybody who knows how to do it. So that makes this radio valuable to a woodworker who might be really interested in having a neat old radio. This would be the perfect one, as long as this is working. And I straighten out the pointer on the front too. So happy day. Now I bet you I'll go today and I will be light on my feet all day, as opposed to yesterday where I just seemed to slug around the house all day. I guess it was kind of a psychological wounding in here yesterday. So I'm not wounded now. So thanks so much for all of you who encouraged me on this. But it's not over yet. See you on the next video.